Hi, I'm going to demo the procedure for time in the sun. You're going to use a Google Sheet to make a chart showing the sun's analemma pattern. So let me show you how to find the files and start the project. So you need to get into the class, and you can go to classwork for Unit 7. And time in the sun is the activity. The files you need are loaded right here. Here's the lab handout, which has the data table you need for the chart and the lab questions. So I have that pulled up on the side over here. You can download it as a Google Doc or as a Word doc or as a PDF. You just need to be able to read off it for now. So here is the time in the sun or lab handout. The data table is on page 2. You're going to enter these values into a Google Sheet. So let's go back here. The Google Sheet is located right here. You can obtain this file and open it, and it'll look like this. So I'm going to minimize these so you can see them together. Here we go. So you need to read and record these values and put them in the outlined rectangles here and here. The numbers in the center will fill in as you enter the two other numbers, so you don't need to worry about that. You don't have to fill this out in the lab handout. Just enter the values in the spreadsheet to make the chart. The chart is right here. It starts off as a horizontal line, and it'll gradually build itself into the figure 8 pattern of the analemma as you type in the numbers. You do need to start off with putting in our latitude. You can type 40 or 41 for Bremen, so I'll put 41, hit enter. That changed the line and made it move up higher, but now you're going to start entering the values here. 22.1 degrees south is a location in the southern hemisphere. To make the chart work, anything that's located in the southern hemisphere or has an S after it has to be negative. So you're going to type this in as negative 22.1, like that, hit enter. And the clock time over here is 12:07, so you need to type in 12:07. Make sure you put the colon. If you type a period, it'll mess up the graph. So you got to type these values in very carefully to get it to work. But so far we have 1 point right here. And you can also line up the dates. January 20th is right here, so 20.3 south. That would be negative 20.3 and 12:11, just like that. And now we have 2 points, and you keep putting these in. Negative 17.9, hit enter, and 12:13. February 10 is 14.6, that's negative 14.6, and 12:14 is the time. February 20, negative 11.2, and 12:14 again. On March 5th is negative 6.4. And 12:12. March 10, negative 4.4. And 12:11. Let's see what it looks like right now after these. You're starting to get the curve pattern at the bottom here. If it doesn't look like this, then go back and check what you're doing. But common mistakes are not putting in the negative for south and not typing a colon, but a period instead. So I can show you what this will do. Let me type 12:11. I guess I didn't change it too much, but or 4.4. Well, as you do this, you'll these problems become apparent as you type in more values. Change those back here. Okay. Let's see, March 20 is 0.5 south. Just forgot the negative. There we go. Negative 0.5. And that is 12:08. There we go. And March 30, now these are positive values, so 3.4. Since it's north, it's 3.4 positive. And the time is 12:05. There you get a nice chart develop itself. Let's see, April 10, 7.6. And it's 12:02. April 20, 11.2. And 11:59. Okay. April 30 is 14.5 and 11:57. There's my graph, nicely forming. May 10 is 17.4. And that is at 11:56. May 20, 19.8. And it's 11:56 again. May 30 is 21.6. And 11:57 again. It's similar to what was before. Okay. June 10th, 22.9. And 11:59. June 20, which is about the summer solstice, 19.8. Wait a second. I'm sorry, 23.4. Yeah, be careful. June 20, 23.4, 12:01. There we go. June 30, 18.7. And that is I read that wrong? Yeah, I did. June 30, I'm sorry, it's 23.2. Oh no, I'm right. Sorry. I was right. Let's see, June 30. No, I was wrong. 23.2. Sorry about that. Good thing I caught that. It'd be embarrassing. June 30, and that's 12:04. July 10, 22.3. And 12:05. July 20 is 20.8. And the time is 12:06. July 30 is 18.7. It's a number I messed up on earlier. And 1206. There you go. Now it's starting to come back down again. And it's going to fill it in eventually as you type the values. August 10 is 15.8. And 1205. August 20, 12.7. And 1204. August 30 is 9.3. So you're approaching the equator now. Eventually it's going to turn south again, and you got to type in the negatives. So that's 12:01. September 10 is 5.3. And 11:57. September 20, 1.4. We're almost at the equinox. And 11:54. September 30, now we're getting negative again, negative 2.5. Negative 2.5. And 11:50. Curious what if I left the negative out, what would it do? Yep, it's starting to look funky. Don't want that, right? Yeah, do that. Okay. October 10 is 6.3 negative. Now we're going below the equator, and it's 11:47. October 20, 10.8 negative. And 11:45. October 30 is 13.5, negative 13.5 south, and 11:44. November 10, negative 16.9. And 11:44. November 20 is 19.5 negative. And 11:46. November 30 is negative 21.5. And 11:49. December 10, negative 22.8. And 11:53. December 20, negative 23.4. That's about what Earth's tilt is. And it's 11:57. December 30, negative 23.2. And it's 12:02. Finished. Now, as a student, you're going to upload this as a screenshot, or I'm sorry, a PDF. Let's look at the graph real quick. Here we go. Looks nice. Summer at the top, winter at the bottom. Go summer over here to autumn, and then down here to winter, and then up here to spring, and then back to summer again. So that's the seasons and how it affects the sun's position. The width of the pattern, it's fatter at the bottom than the top. That's because the Earth's orbit is not a circle, it's an ellipse. So in the winter, we're actually moving faster around the sun because we're closer. I know it sounds backwards, but we're closer in the winter. And it makes the pattern stretch out more. We're closest around January 4th. That's when we're at perihelion, which is the closest point between Earth and Sun. And again, it is opposite to the seasons, so that's an indication that that's not the cause of seasons. The Earth's tilt of 23 degrees is the actual cause of the seasons. And that tilt is shown. The pattern moves 23 degrees above the middle and below the middle, which would be the equator. And that tilt of the Earth creates the vertical portion of the chart. So Earth's tilt combined with Earth's orbit Earth's orbit being an ellipse, not a circle, creates this pattern that we see as an analemma. It can be photographed, it can be marked with a shadow tip. There's many images on the internet of the analemma taken by amateur astronomers. But this is our own version in the chart. But you're going to go to File and download it as a PDF document. Let's see what this looks like here. Oh, it looks great. So I'm going to export that. And then I would save this. In the Canvas quiz, there's a question that will prompt you to upload your PDF file. So you'll do that, and that'll be worth points also in the Canvas questions. So let's see what this looks like here. Ah, perfect. Yeah. So you need to do this yourself, though. Okay, you can. I think I've demonstrated the procedure. So that's it for this lab demo. And just contact me if you need any help. Since we're virtual, you can email me or use the chat feature in Zoom. But good luck with this, and I'll see you later. Let's see here.